All right. Hope everybody's doing okay today. We are done with the previous lesson. You have your homework. It's going to be due when? Monday. All right. So your homework is due Monday. We'll grade it, talk about it, and we'll go ahead and finish up. What we're about to start, we're looking at the inverse other three trig functions. Hey, hello. Hello, Max. Oh, okay. All right. So let's see here. We actually should have a little bit of time in class today, more than yesterday, to go ahead and work on the assignment. The other classes have been getting about 20 minutes, so pretty decent amount of time. We'll go ahead and start trig identities next week, but that will not be on what? Next Friday. The test, because we are not going to be able to finish that before the test hits. So the test, be looking over all of your inverse material. Be sure you know what quadrants to go ahead and draw your triangle, all that good stuff. The other portion of the test is going to be from graphing the trig functions, but that's going to be a smaller portion. In fact, your quiz from a couple days ago, that's pretty much what to expect. Okay, it's going to be the exact same format. It's going to look exactly the same, just a different function. All right. Any questions on what's going to be happening? All right, well, let's go ahead and get to it. Now, let me take one step back on my slides here. I went ahead and provided you this page because the top three rows, these are intervals that we're already very familiar with. What goes into an inverse trig function? Is it a ratio or an angle? Okay, it's a ratio. Whatever you put into an inverse trig function is a ratio. The answer you get is going to be an angle measure, depending on, degrees or radians. So you can only put ratios between -1 and 1 into both sine inverse and cosine inverse. Remember, anything was available to tangent inverse, but then the answers had to be restricted to certain parts of the unit circle. Both sine inverse and tangent inverse were restricted to quadrants 1 and 4. The only difference being that tangent can't include the boundaries that we have. And cosine inverse was going to be restricted to the top half, quadrants 1 and 2. And the thing about these other three trig functions, I'm not going to go as in-depth with the previous three as we did earlier in the week. I'm going to go ahead and just show you the reciprocal method so you can evaluate them. But I'm not going to show you the graphs. We're not going to do any of that. We're only going to spend a couple of days on this at most so we can get into trig identities. But just for anybody who was curious or who wanted to go ahead and dig a little deeper, I did go ahead and provide the domain and the range intervals for the three we're going to go ahead and start to look at. Okay, so you do have those available to you. And I will reference one of these on our first example. So let's see. We got a couple of columns here. Exponent notation. It says verbally, secant inverse of 2 means the angle whose secant is 2. So if we're given secant inverse, cosecant inverse, or cotangent inverse, we're going to take the inverse of that function, and we're going to take the inverse of the ratio that's being input. So secant inverse of 2, well, we're going to go ahead and evaluate cosine inverse of 1/2. And see, as soon as we take that reciprocal, well, we already know how to deal with inverse sine, inverse cosine, and inverse tangent. The only one that gets a little tricky is when you're dealing with cotangent inverse. So depending on the ratio that you're given, if it's positive, well, then we're going to want to do this. If it's negative, we're going to go ahead and take this one in the middle, which is the previous. We're just going to add pi to it. If it's 0 itself, well, then the answer is just pi over 2. That one case, we don't have to do anything. Okay. And the only other thing that's on this page that I want to go ahead and bring up, you'll see all of these trig functions now have arc in front of it. So when you're reading an expression, how do you know we're dealing with an inverse trig function? What indicates that? Yeah, that little -1, right? So if you see this written, we're going to read that as the inverse of sine inverse. We know that x has to be a ratio. The answer is going to be an angle measure. So this is just another way to write it. It's a new notation. So sine inverse of x can also be written just by putting the word arc in front of the sine, or any trig function. Okay. So arc is just another way of telling you we're dealing with the inverse instead of writing the -1. So cosine inverse of x is just arc cosine. Okay. Tangent inverse is just arc tangent. Applies to all of them. All right, so don't let that throw you off if you see that. Okay, well, I think the best way is just to get to an example and see what you guys think. Find the exact value for each of the following. And again, we don't want to use calculators. The way we're going to go ahead and start to look on this, I would encourage you to do it on the homework, because the test next week, you're not going to have a calculator. If it turns out you have a special right triangle, you're going to go ahead and give me the answer in radians, because we're already very familiar with those angles. If it's not a special right triangle, then your answer we're just going to leave in degrees, because you're going to have to measure it using your protractor. Okay, and I'll be mentioning this as we go along, even when we get to the homework. So let's see. Arc cosecant of 2. Well, what does that arc mean again? Yeah, that's just inverse. Arc cosecant of 2 is exactly the same as if I said cosecant inverse of 2. All right. Now, to evaluate these new trig functions, these inverses, well, we're just going to take the reciprocal. What's a reciprocal of cosecant? Ooh. Sine. So I'm going to write sine inverse, and I'm going to take the reciprocal of the ratio, 1/2. Okay. We're just going to rewrite it, and see, this becomes a problem that we've been solving the entire week. So we're already very familiar with this, so that's really the only new aspect to this lesson. Remember, sine inverse, he's restricted to quadrants 1 and 4. So Stephanie, what quadrant would 1/2 put me in? 1, because it's positive. Okay, so we're doing the same thing. I'm going to draw in quadrant 1 a terminal side. I'm going to connect it to my x-axis, create my right triangle. So this reference angle right here, that's what we're looking for. Okay. Now, what ratio does sine have? It's what over what? Okay, so it's the opposite y over the hypotenuse r, okay, or the radius. Okay. So this would be 1, this would be 2. And just like before, we want to use the Pythagorean theorem to help me figure out the missing side. Connor, do you know what that is? Hey, he says the square root of 3. Does anybody want me to run through the Pythagorean theorem to show that we're going to get that? No? Okay. Well, Raphael, is this a special right triangle? Yes. What is it? It's a 30, 60, 90. The hypotenuse is double the shorter leg. The longer leg is square root of 3 times the shorter leg, so absolutely. But this one that we're looking for right here, is that 30 or 60? That is 30. Here we go. That one would have to be 60. So my answer here, the theta that I'm looking for, is 30 degrees. But remember, if it's a special right triangle, we want to write our answer in radians, which would be pi over 6. Okay. Again, see, we're looking at brand new inverse function. Don't need a calculator in order to get it. Okay. In fact, let's see if we're correct. So I'm going to go to my calculator right here. When I hit trig, see the bottom row are all my inverse trig functions. This time we're using cosecant, inverse of 2, and mine's in degrees, so it does give me the 30. If it were in radians, then it would give you the decimal equivalent of pi over 6. Okay. All right. Any questions on how we did that? Anybody confused? Okay. Well, let's try another one. Secant inverse of negative square root of 2. Okay. Jane, what's the reciprocal of secant? Cosine. All right. So I'm going to rewrite this as cosine inverse of what should be my ratio? There you go. But negative 1 over square root of 2. Taking the ratio doesn't change the sign. Okay. All right. So secant inverse of negative square root of 2 became cosine inverse of negative 1 over the square root of 2. And the question came up, and I think I might know what you're about to ask. Do we have to rationalize? Oh, no. Okay. So what's your question? Oh, because we're solving by the reciprocal. Just like over here, when we had cosecant, we changed it to sine. Okay. So in order to evaluate these new inverse functions, we're doing so by taking the reciprocal function. Okay. Now, there's other ways to do it. You can go ahead and still create the triangle, but I'm not going to spend time talking about where these are restricted like we did the others. We're just going to go ahead and take the reciprocal because you're still going to be able to get the same answer. And in the long run, it's not necessary. I've even talked to Mr. Heinrich about this, and he says this is the best way to do it. Okay. So I said, okay, that's perfect. All right, so is everybody okay with what I've done so far? Hey, one. Oh, well, it really doesn't matter. You could keep the negative down in the denominator if you want, as long as the value itself is still negative. Now, why is that important? Because it's got to tell me what. There you go. So what quadrant would I be in? Okay, it'd be in 2. Yeah. X is negative in quadrant 2. All right. So I'm going to connect this to my x-axis, just like that. Okay. There's theta. All right, now, forget about the negative for just a second. What's cosine's ratio? It's always adjacent x over the radius, the hypotenuse r. Okay, so I'm going to go ahead and put 1 and the square root of 2. Now here you have to decide where does that negative go. It's got to go on the 1. Remember, in the triangles, that radius, the hypotenuse, will never be negative. Always positive. Okay. Well, let's see here. Rhett, can you tell me what that missing side is? It's 1. Does anybody want me to run through Pythagorean theorem to show you that it's 1? Okay. All right. Now, is it a special right triangle? Yes. Which one? Well, wait a minute. That's a 1. That's a negative 1. There you go. We're talking about the lengths. The negative just tells me direction. Okay. So, yes, this is a 45 right triangle. So what's secant inverse of negative square root of 2? There you go. Okay, now the microphone probably didn't pick up what he said. Say it a little louder, sir. He said 135 degrees or 3 pi over 4. Why is my answer not 45? What am I forgetting? There you go. If it's cosine inverse and you're in the second quadrant, you always start rotating from standard position. So the 45 is just going to help me figure out what my true angle is. See, we don't have to do that in quadrant 1. All right, so he's absolutely right. If I took the whole measure, the 180 minus the 45, that's 135 degrees, or it's equivalent to 3/4 pi. Okay. So is anybody having problems with the new inverses? Okay, we take the reciprocal, you're good to go. All right. Now the next two are cotangents. Okay, so that's where it gets a little tricky. Let's take a look at what we have here. Cotangent inverse of negative square root of 3. Okay, so what's the sign of my value, my ratio? Is it negative or positive? It's negative. Okay, so I'm going to look back up here at the expressions that I was giving you. Because that input is less than 0, it's negative, this is what I want to do. Tangent inverse of 1 over x plus pi. So we're still taking the reciprocal. I just need to take my final answer and add pi to it in order to ensure that I get the right answer. Okay, so let's come back over here. Cotangent inverse would be tangent inverse if I took the reciprocal. What's the reciprocal of the ratio? Okay, so we can say -1 over the square root of 3. And if you wanted to keep the square root of 3 negative, that's fine. Okay, and then plus pi. Remember, because it's coming straight from that little piecewise function that I provided you. Okay, now don't worry about the plus pi. We won't even look at him until the very last step. Okay, all I want to do now is evaluate tangent inverse of -1 over the square root of 3, just like we've done in the past couple of days. Okay, Aiden, what quadrant would this put me in? Okay, well, let's take a step back. What 2 quadrants is tangent inverse restricted to? That's right. Okay. Say it with a little more confidence. There you go. All right. So out of the 2, Aiden, which one would it be? Why? Because it's negative. There we go. All right, so in quadrant 4, I'm going to draw my terminal side. Connect it to the x-axis. There's my right triangle. Okay, so here's my theta. Okay, now what ratio does tangent have? It's always opposite over adjacent. So the opposite y over the adjacent x. So this would be 1. This would be the square root of 3. All right, which one's negative? The 1. Okay, because y is negative in this quadrant. And if I were to use the Pythagorean theorem, what would I get for the radius, the hypotenuse? It is 2. Again, does anybody want me to write that out to show we would get that? Okay. So what's theta? Okay, it's 30. This is a 30, 60, 90. Now we want to be careful. While this one is 30, I want to make sure to put negative 30 right here. Because remember, we're in what quadrant? If you're in quadrant 4, you've got to rotate clockwise to get in there. Because remember, we still have that limitation. It's got to be between negative pi over 2 and pi over 2. All right. Now, I'm going to go ahead and change one more thing. Instead of taking negative 30 plus pi, I mean, we could go ahead and say negative 30 plus 180, but there's no fun in that. What's the radian equivalent to negative 30? Negative pi over 6. Okay, so doing what we've always done, the tangent inverse gave me negative pi over 6, but in order to solve cotangent inverse of this, remember, according to that piecewise function, we just now have to add pi. Okay, so what would that be? Would you say 5 or 7?
7.
Ooh.
Oh, it's negative.
5 pi over 6. There you go. And if you were to convert it to degrees, what negative 30 plus 180 would be 150, which is what 5 pi over 6 is. Okay. All right. Now, let's check that. Let's see if it works out. Cotangent inverse of the negative square root of 3. Okay. I'm going to go ahead and plug this in. Cotangent inverse of the negative square root of 3, 150. So we got that perfect. Okay. Now remember, you only have to add pi if the ratio for cotangent inverse is negative. If it's positive, you'll simply take the reciprocal. If it's 0, your answer is pi over 2. You don't have to worry about anything else. Right. Anybody having trouble? Okay. Let's take a look at this last one. Arc cotangent of 1. Remember, that's just cotangent inverse of 1. Would anybody want to come on up and show me how to do this one? Okay. Now, what kind of ratio do I have? Positive or negative? Positive. So because I have a positive number, all I have to do is take the reciprocal. I don't have to do anything additional. Okay. So who wants to come on up? Christian? Oh, yeah, we'll help you out.
Okay.
We'll help you out. Okay, remember, we want our final answer in radians. Okay, so tangent inverse 1 over 1. Okay.
Yeah. And then,
so what quadrant? 1 or 4? Okay, it's positive.
and then, do you want me to do
The hypotenuse?
yeah.
You can. What would the hypotenuse be? Square root of 2.
Yeah.
Okay. Now, you could, but you don't actually need it to solve the problem. Yeah. So.
Okay. So I can just say.
So it is a 45, 45, 90. So what is 45 as a radian?
45 is a radian. It's pi over. Yes, 4.
There we go. Pi over 4. That's exactly right. Okay. Perfect. That's all there is to it. And if you were to go ahead and plug this into your calculator, okay, if it's in degree mode, it should give you the 45. And if it's in radians, I want to say it's going to be 0.7 something. I don't remember what that decimal is off the top of my head. Okay. Anybody having a hard time? Any questions? Okay. I've got one last problem, and then I'm going to go ahead and give you the rest of the time to go ahead and work on your assignment. We could probably even work one together if you want. Okay. But let's see. Example 3. These were kind of skipping around. I didn't take the entire resource. That's why the numbers don't match up. But find the value of arc secant of -3/2. So let's say I were to give you one of these. Okay. Well, how would I rewrite it? Okay. Arc cosine of -2/3. There you go. You take the reciprocal function and the reciprocal of the ratio. It's only cotangent inverse that you have to be careful. Okay. All right. Well, let's see here. What quadrant would that put me in? 2, because it's a negative ratio. All right. So I'm going to draw my terminal right there. Okay. Connect it to the x-axis, just like we always do, create my right triangle. Okay. So I'm looking for this theta right here, the reference angle. Now, will that be my final answer? Okay, Bethany, you're already shaking your head no. Why? There you go. We call that what position? Standard position. So whatever theta is, it can help me figure out what my true answer is. If you're in quadrant 2, remember you have to start from the positive x-axis. Okay, standard position. All right, so let's see here. We've already seen cosine is the adjacent x over the hypotenuse, or the radius r. So this would be 2, this would be 3. Because we're in the second quadrant, the 2 would have to be negative. Okay. Let's see here. What is the height? √5, yes. Okay, and again, does anybody want me to write that out to show that we would get square root of 5? Okay. Now you probably had a clue as soon as I turned to this slide. Okay, what are we going to have to do? We're going to have to measure it. Okay, because I've already got those tools right there. But also, if you're looking, this is not 45-45. This is not a 30-60-90. Okay, the sides don't follow any of those relationships. Okay. Now, the 2, we're going to be able to measure that pretty easily. I like to measure in centimeters, so we can get that exact. But let's go ahead and get the square root of 5. Okay. In fact, does anybody know that off the top of your head? It's got to be a decimal between what 2 numbers? 2 and 3. Would it be closer to 2 or closer to 3? Closer to 2, because the square root of 5 is closer to the square root of 4. So what would you think? About 2 point what? About 2.2? There you go. Very good. Okay. So let's say 2.2. Now we want 2.2 centimeters, so we've been converting that to millimeters. So we probably don't even have to multiply by 10. It's just going to move the decimal, but I'll go ahead and do it anyway. So we're looking for about 22.3 millimeters. Okay, so here's what we need. I need a triangle right here in this grid that I've created that's going to be 20 millimeters by about 22.3 millimeters. That was the decimal, right? Yes. Okay. And then we'll go ahead and measure it. So I know a lot of people have been very anxious to come up here and use the protractor and the rulers because they're awesome. So who wants to come up here, create the triangle, and then show us on the protractor what the answer is? Okay, so many hands going up, but I just need one. Okay, well, let's do it this way. Christian, you were the last one to come up. Who would you like to see measure this angle?
I don't know.
You don't know anybody?
Yeah.
Then give me a number between 1 and 36.
12.
12. All right. Yes, you are 12. She says, oh man, I'm chosen. Yes, that's awesome. Okay. Now we're going to help you out. Okay. So how do you use this? Well, it's just a touch screen. So we are in quadrant 2. Oh, that's okay. Just touch it right in the middle. There you go. Now we want to go horizontally 2 centimeters. Now this is my origin right here. So we want to go 20 millimeters by about 22 millimeters. So I would go ahead and place, there you go, the 2 on there. Perfect. And you could even just go ahead and do this. Instead of marking it, you could just now pull him over and then just connect the 2. You see what I mean? Now we'd want to connect it, there you go, I'd say that's perfect. Now let's make a mark where you think 22.3 millimeters is. Okay. Oh, it's not erasing it? Hey, it's okay, just draw another dot. So you're thinking right about there? Okay, so let me go ahead and do this. I'm going to draw a segment going from the origin through that guy right there. Okay. Now, let's put your protractor on there and see what we get. Okay. Now, are my crosshairs right on the origin? Okay. All right. So what do you guys think? You're saying about 132? Now wait, why are you going 132? It looks, that reference angle doesn't look that big. Remember, you have to rotate from the positive x. Okay. So we're saying theta is about 132 degrees, right? Good job. Okay. Did it rule getting to use those things? Because it's a ruler? Okay. But let's see how close we actually are. All right. Because remember, what's going to happen on the test? You're going to have about 5 above and 5 below, you know, whatever I take the answer to be. So here, she can go to 137, or what's the lowest we can go? 127. There we go. Okay. So let's come on over here. What was it? It was arc secant of -3/2. So I'm going to come on over here, trig secant inverse of -3 divided by 2. We said 132, 131.8. So how well did she do on measuring? She did a really good job. Fantastic. She pretty much nailed it. Okay. So remember, that's what's going to happen on the test. If you end up with a special right triangle, you'll just give me the radian measure. If it's a triangle that you have to measure because it's not special, then you'll just give me the degree measure from your protractor. Okay. All right. Any questions? Anybody having a hard time? Okay. I've got 10:34. We get out of here at 52, so we have right about 18 minutes. Let's go ahead and work on our assignment. Has anybody finished it? No. Okay. Did anybody want to work a problem together? Okay, let me go ahead and take this off. Okay, let me go ahead and pull this up. Now, very quickly, don't forget, has anybody had the opportunity to look at the video I talked to you about yesterday? You have? Did you work the extra problem? Okay. It's only 10 minutes long. It's not going to take a lot of time. I did put a problem like this on your test next week. Okay, this video is listed on the website. It's only 10 minutes. And I give you an additional problem to go ahead and practice. And you can check throughout the week next week if you want to check your answer with me. That would be perfectly fine. All right. Now, the thing on this, I would really encourage you, especially on the sections where it says, you know, go to the calculator, don't immediately go to the calculator. Okay, try to find these values by hand, then go to the calculator to get the number of decimal places to see if you're accurate. Okay, because remember, you won't have a calculator when it comes to the test. Now, I'll go ahead and tell you, on my key, numbers 1 through 18, I gave all mine in radians. Okay, but as long as on the homework, if you gave it in degrees, if it's equivalent, that's still going to be fine. Okay, So is there any question on the homework we want to take a look at? $25? $25 actually has been a popular one today. Okay. You'll notice I've already got the tools up here, so we're not going to go to the calculator. We're going to use the protractor to kind of help us out here. All right, so let's see. It says a remote camera at ground level is filming the liftoff of an Atlas rocket at a point 800 meters from the launch pad. Let theta be the angle of elevation to the rocket, and let S be the height of the rocket. Now, this is the height of the rocket as it's off the ground. That's not the height of the rocket exactly. Find theta when S equals 1,500 meters. Okay, so let me go ahead and redraw this triangle that we got going on right here. So we're trying to find theta. Okay, so what do I know about this triangle? Okay, we know what? We know the base is 800 meters. And we also know the height's what? 1,500 meters. Okay. Now, we can solve for the hypotenuse if you want to, but actually, with theta's perspective, we've got the opposite and the adjacent, so we actually have everything we need. What function could I use? We can just go ahead and use tangent. Now, I would go ahead and suggest one thing, especially since we're going to be measuring it. We probably don't want to measure 800 centimeters by 1,500 centimeters. So you'll notice they're both divisible by 100, so we can considerably knock those down. Okay, we just took a ratio. All right. So we're trying to solve tangent inverse of 15/8. Okay. Now, what quadrant would I be in? Quadrant 1, because 15/8 is positive. Okay. So we'd want to measure out a triangle that's 8 centimeters on the base and 15 centimeters high. And luckily, you'll notice my ruler does go all the way to 15 centimeters. Okay. So now I just need somebody to come on up here and help me measure out the angle. Okay. So, ma'am, you were the last one up here. Who would you like to see measure this out? Sure. 27. Who's 27? Oh, is that Zach? Okay, he's not here, so I need another number. Well, that's fine. If you want to choose 11, that's cool. I'm sure Dylan won't mind. All right. Here we go. Okay. So you know, yeah, I've already got this set up for you because we got to go 15 centimeters high.
Yeah.
Okay.
Alright, so mark it at 8.
Okay, so that's 8 centimeters. Good. Oh, and I've already got the other ruler over there if you want to use that.
Yeah.
Okay. See, that way I don't have to keep rotating it. Oh,
That's too high.
a little high. Okay. And now I'll do just like I did for Ariana. Connect it right up here to the point that you made. And now I'll let you move that protractor. Okay, crosshairs right on the origin. Okay. So what do you think? 62? Okay. Would everybody agree? Is that the answer you want me to put? Okay. So theta is about 62 degrees. Okay. Now, let's see how close we actually got. See, this is what I'm talking about. Try to do it by hand and then go to the calculator if it wants, say, a certain number of decimal places. This will give you practice and make you feel better about using that protractor. Let's see, we were doing tangent inverse of 15/8. So let's see here. Trig, tangent inverse, 15 divided by 8. We said 62, 61.9. I think those are the best measurements we've had all week. That is perfect. There you go. So like on the previous sections where it was saying 2 decimal places, 61.92, this one I would probably just go ahead and say 62. Okay. On the answer key for this one in 26, I did give both the degree and the radian measure. Okay. All right, so good job. All right, anything else? Well, okay, I'm going to go ahead and let you guys do your thing. You still have a good 10 minutes, so there you go. Let's get out of here. Why would this not? Document B. There we go.